So in this video, I will talk about the Earth's magnetosphere. And for the definition, a magnetosphere is like a region around a planet, and it is dominated by the planet's magnetic field. And other planets in our solar system have magnetosphere, but the Earth has the strongest one of all the rocky planets. And the Earth's magnetosphere is a vast and comet-shaped bubble which has played a crucial role in our planet's habitability. And the magnetosphere, it shields our home planet from solar and cosmic particle radiation, and we should care about that for two main reasons. The first is that the solar wind, and it is a continuous stream of charged particles, and mostly protons and electrons, and so it ejected from the sun, and it could have significant impact on the Earth, as it could push away and reduce the atmosphere thickness, and it could be very dangerous for life on Earth. And the second is that the solar wind could lead to radiation exposure, and it can be harmful to humans because the ionizing radiation has enough energy to remove the loosely and tightly bound electron from atoms, and creating ions and free radicals. And this process means that it could destroy the living cells of our body, and including the structures and the genetic material, and it's very dangerous. So the Earth's magnetic field, or the magnetosphere, what caused it? So it was generated by the convective motion of charge, and also convection is the movement of particles through a substance, and it's like the movement of the electrically conductive fluid, and primarily mostly molten iron and nickel in the Earth's core. And the rotation of the Earth and the convective motion of this conductive material has generated electric current, and which in turn it produced a magnetic field through the geodynamo process. And actually in physics we have something called the dynamo theory, and it proposed a mechanism by which a celestial body such as the Earth or a star could generate a magnetic field. It's it describes the process through which a rotating and convecting and electrically conducting fluid can maintain a magnetic field over a very long time in astronomical time scales. So the dynamo is thought to be the source of the Earth's magnetic field. And there's something about the magnetic field shape that we can see here. Actually, the constant heat and being phased by the solar wind, it has compressed the side of our magnetic field that is facing the sun. So this sun facing side, or day side, it extends a distance of about 6 to 10 times the radius of the Earth. And because it has been compressed and is not as large as the other side of the magnetosphere that face away from the sun. Actually, we call it the night side, and it stretched out into a very large length, and it can measure hundreds of Earth's radius, and it's even past the moon's orbit of the Earth, and the moon orbit at the Earth is about 60 times the Earth's radius. Also, within the magnetosphere, there are two regions known as the Van Allen radiation belt. These are the zones of charged particles, and primarily electrons and protons. It has been trapped by the Earth's magnetic field, and when these charged particles from the Van Allen belt enter the Earth's atmosphere, near the polar region, so they will collide with the neutral atom from molecules in the upper atmosphere, and typically oxygen and nitrogen, and this collision excited the atmospheric particles, and when they return to their normal state after the collision and the excitation by those charged particles, those oxygen and nitrogen will emit the light that we see, and this process is what created the beautiful natural light display, and we know about it as the auroras. That is some information about the Earth's magnetosphere.